Hello everybody. So we'll be doing video notes on vectors day 2. I gave you this warm-up on the board to start with. I'm going to write down the correct answers just to make sure and see if there are any questions. So for the two vectors that are given, W and V, we're asked to add them first and subtract them second. So when I add V and W together, I add my i's, which are like terms. I get 1 I. I add my j's together, and I get 7j. So my answer is I plus 7j for number 1. For number 2, when you subtract, just be careful. You have to distribute that negative when you subtract. So I get negative 5i, and for the other part, I get negative j. For 2v, for number 3, I'm just multiplying 2 times the v component. So when I do that, I get it to be negative 4i, plus 6j. For number 4, it's the same thing, except here I'm multiplying 3 times the w, and I get it to be 9i plus 12j. For 5, I do have both answers above. I have the 2v and the 3w, so all I need to do is subtract those two quantities. And when I subtract those two from each other, I get negative 13i minus 6j. For number 6, don't forget what those bars mean. That means magnitude. So magnitude is doing the absolute value of your a squared plus b squared. Don't forget that your a is located in front of the I, and that your b is located in front of the j. So for w here, I have my a as 3 and my b as 4. So when I plug in both those things, square and square root them, I get it to be 5 for the magnitude. Okay, so today's objective is to be able to find a direction angle and vector in a component form, meaning what's the ai plus the bj besides using the angle. Don't forget about your Khan Academy homework assignment that's due next Tuesday, the 10th. All right, so this slide I definitely need you to copy in your notes. So definitely pause this and put this in your notes. So we have both a vector in our component form here. This is what it is. So this is the component form of the vector. I have them separated down to make life easy for us down here. So I need to figure out what the angle is between the vector and the positive x-axis and multiply that by, again, the magnitude here. This is the formula for the direction angle. I'll be using all 3 of these things to help me get the answers. All right, so for the first 2 examples, we're going to be finding just the direction angle for the vector. So what angle is this vector going in? So the formula says I'm going to be taking tangent to the negative 1, and in parentheses is your b divided by your a. Most important now is to go get a calculator, and please make sure it's in degree mode. So pause the video if you need to. All right, for number 1 there, again, your a is in front of the I, so that's 3. Your b is in front of the j, that's negative 4. I'm going to write down inverse tangent of negative 4 divided by 3. Go ahead, try this in the calculator, pause the video, and see what you get. Okay, so I get it to be negative 53 degrees. All right, the next example for number 2. Again, A is 7 and B is 6. I'm going to plug it in the formula, pause the video, and see what you get. I get it to be 40.6 degrees or 41 degrees there. All right, and we'll be using these angles now on our next slide, which is finding the actual form of the vector. All right, here's the first example. I wrote it and split it up into steps to make it easy. So we're trying to find a vector whose magnitude is 5 and is in the direction of another vector that's negative 6, 8. So we want to find what is this vector in its component form. So we're going to be going through steps 1, 2, 3, and 4. So definitely pause the video as we work through this question. All right, so for number 1, we want to find the direction angle first, which we did before in the other 2 examples. All right, so we're doing inverse tangent. Again, your B is 8, your A is -6. Put this in the calculator and see what you get. You get it to be -53 degrees. This is our angle that we will be using. Now let's take a look at what's the formula to find A. If you go back to the previous notes, the previous slide, it says that A is equal to cosine theta times its magnitude. So we have our theta, which is this -53 degrees. So we're going to have cosine, -53 degrees in parentheses. And then I'm going to multiply it by the magnitude, which is given as 5. Go ahead, make sure you close the parentheses around the angle, and try this in the calculator. All right, I get the answer to be 3. So that's my A part of my component as 3. Next part, I gotta find the B part, the B component. And that formula from the previous slides says it's sine of the angle, and I'm gonna multiply it by the magnitude also. So my angle was -53 degrees. Close that parentheses. And again, magnitude was 5. When I plug that in the calculator, I get it to be -4. Okay, so I have my answer. My component form could be written as 3, -4, or I could write it as 3i minus 4j. All right, here's the second example. Same as the one before. So if you want to try it yourself by looking at the first example and pausing the video, please do so. Here you're finding a vector whose magnitude is 12 and is going in the direction of a vector of -9, 10. So let's find the direction angle first. All right, when I use my inverse tangent of B over A, 10 over -9, put that in the calculator, I get the angle to be -48 degrees. Now let's look for A and B. Right, when I plug in my cosine of my angle, times it by the magnitude 12, I get A to be 8. Now I'm going to look for B. When I plug in my angle, sine of it, times it by the magnitude there, I get it to be B to be -9. So my component form is 8, -9, or it could be 8i plus -9, -9j. All right, so when you're done with these notes, now is when you're going to be picking up your copy of this mini golf activity, which is basically what we just did from before, doing the component form of a vector. Pick that up from the teacher. Pause the video. We're going to do number 1 together, which is whole number 1, because we need to talk about how to find the component form of a vector shown on a graph. All right, so you got the holes on one side and then the scores to put on the other side. We're going to do whole number 1 together. All right, so let's all take a look at the whole number 1 graph. Here I have a snip of it here. Here's the hole starting right there, and it's going to end up here. Right, we need to first now figure out what our X and Y is for this first arrow. So one thing I just want to stress is that this is just like if you were on an X and a Y axis. So if you're going left to right, it's either positive or negative. And if you're going up and down for the Y, again, positive or negative. So let's take a look at the first line here, which is this one, right? It is going up, and how much is it going up? 1, 2, 3, 4. So that means that on my whole 1, the Y, that's the Y-axis, would be 4. How many times is it going this way? 1, 2, 3 to the arrow. And horizontally, that means your X-axis, but it's going to the left, so that means that's negative. That's -3. All right, taking a look at our next vector here, our next arrow. It's going from here to that arrow down there. All right, how much is it going over this way, which is on the X-axis, 1, 2, 3, but again, it's to the left. So that's -3. So I'm going to put -3. And then here it's going down, 1, 2, 3. And then going down vertically is our y-axis. I'm going to put -3 there. All right, our last vector here. It's going straight down. There is no movement along the x-axis. So that one I could definitely make it as 0. And how many times is it going down on the y? Looks like 2 boxes, so it's -2. Oops, -2. All right, so once you've got all the x and y's for each of those vectors, those arrows, we're going to make a total. So for this column here for the x's, it adds up to -6. For this column here, we got it to be -1. Now we are looking for the magnitude of the result. So don't forget the magnitude was taking your a squared plus your b squared. Well, in this result here, our a is our x, so that would be the -6 squared. Our b is our y, -1 squared. Go ahead and put this in the calculator. I get it to be 6.08 is your magnitude. The calculation for the angle, so that's doing tangent to the -1 of b over a. So I'm doing inverse tangent. Our b is our y, so it's -1 divided by -6. Go ahead and put that in the calculator. I get that answer to be an angle of 9.46 degrees. So I have my result and my angle there. So my result is, I went 6.08 meters, and my angle was 9.46 degrees. Okay, so if you're not sure, I would look over again the example for hole 1 with what I just did on the video. Work with someone to help. There are 8 left of the holes, 9 total. Take a look at hole number 2. See if you could get the values of the x and the y for each vector, each arrow as you go from the opening to the hole. And then from there, it should be simple enough to use your formula to get the magnitude and the angle calculation. Once you're done with all 9 holes, please hand this in to the teacher. And then you guys could go ahead and start your Khan Academy assignment, the homework, or finish if you didn't. All right, so once that's done and you've checked your answers, hand it in and work on the Khan Academy stuff. And I'll see you all next week on Tuesday.